Hi, so welcome to another video. So in today's video, I'm going to talk to you about how to determine the color of a particular transition metal complex. So if you're given the wavelength of that particular compound, it really helps you to determine the color. So the quickest way to do it is to use the wheel of complementary colors. So when you're determining the color of a complex, for color to occur, the compound must absorb a particular wavelength that's within the visible region of the color spectrum. So that's where the wheel of complementary colors comes from. And the amount or the wavelength that's absorbed, the opposite is actually the color that you view. So that's why it's in a circular representation. So if you look at your wavelength, go opposite to it, and that will tell you what the color of the actual complex is. So if we have a look at this example here, so we have a compound that absorbs a wavelength of 500 nanometers. So this is within the region. So the visible region is from 750 all the way down to 400 nanometers. So looking at the wheel of complementary colors, you can see 500 is within the green region, which is 490 to 560. So if that's where the color is absorbed, then the opposite color will be what we see when we look at the compound. And the opposite color for that will be in the red region. So it will be from 750 down to 650 nanometers. So you can easily predict the color if you're given the wavelength in nanometers. You can just use this here. It gets more complicated when you're not given the wavelength and you're given a bit of a puzzle, and that ties into crystal field theory, and there's other videos that explain this in a little bit more detail, and I'll link them below for you. So thank you very much for watching. Remember, the wheel of complementary colors is your key to determining the colors of your transition metal complexes. So thank you, and I'll see you next time.